Okay guys, 10.5 is called angle relationships in triangles. Our objectives today are to find angle in arc measures and then use circumscribed angles. So if we take a look at this first box here, there's three situations we need to differentiate from. Okay, we need to be able to determine, okay, where are the lines intersecting? Okay, so if I look up at the top left, it says lines that intersect on the circle. So you have a highlighter, or maybe circle that, I don't know. But if the lines are intersecting on the circle, we're going to have a rule. Okay? If the lines are intersecting inside the circle, we're going to have a rule. And if the lines are intersecting outside the circle, we're going to have another rule. Okay? Now, I believe we already know the first one. Because if lines are intersecting on the circle, isn't that kind of like what we learned about last class with inscribed angles? Because if I were to draw a circle here and I draw an inscribed angle, would you agree with me that these two lines, this angle right here is inscribed? Would you agree there? So we know that if an angle is inscribed, the angle of this, or the measure of this angle is going to be half of the intercepted arc. Okay, that's the same thing here. So if two lines are intersecting on the circle in this situation, where I've got a tangent line and a chord, okay, and they intersect right there, these angle measures, so for example, the measure of angle 1 is going to be the same exact thing as inscribed. It's going to be half the measure of the intercepted arc. So if I look at angle 1, it is going to be half the measure of this intercepted arc. So it's going to be 1/2 the measure of arc AB. Maybe you want to put right here and maybe a little star there and say half the measure of the intercepted arc. Okay, so really guys, that's not new. The next two are a little new. So the second scenario is when they intersect inside the circle. Okay, so if I'm going to find the measure of angle 1, that is going to equal the average of these two arcs. Okay, so since angle 1 is right here, we're going to go across from those two, and it's going to be the average of this intercepted arc and that intercepted arc. So in this situation, it's going to be 1/2 the measure of arc AB plus the measure of arc CD. It's the average. We're going to average the measures of the intercepted arc. Here we go. Put a little star and say average of the intercepted arcs. Shane, question?
It says that you would take 1/2 of the measurement of the arc AB plus the measurement of the arc CD. Do you do half of both of those, or you just do half of one and then add the full?
I think we'll get. Let's wait till we get an example like that, and then I think that might clear it. We're going to add them together, and then we're going to times it by half. We'll get to an example like that. Okay? Now the next one, the third and final situation, is when the two lines are intersecting outside the circle. Okay? And if they are intersecting outside the circle, here's our formula. And it's going to be this measure of the angle. So the measure of the angle, and I don't want to put angle 1 or something like that, because in this example it's angle 1, this example it's angle 2, in this example it's angle 3. Okay, so kind of talk about this a little bit. If I look at this line right here, guys, what type of line is that? Going back all the way to section 1. It's a secant line because it goes through the circle and intersects at 2 points. What type of line is this? Tangent. So I got a secant line and a tangent line. Over here I have 2 tangent lines, and here I have 2 secant lines. Good. So it doesn't matter. It's all about where they're intersecting, and they're intersecting outside of the circle. So this angle, the angle here, the angle there, the angle there, that is what we're finding with this formula. And I'm not going to put angle 1, I'm just going to put the measure of the angle is going to equal 1/2 the big arc minus the little arc. Okay, and what I mean by big arc, and guys, you guys can keep it. I'm gonna write that in blue. You guys don't need to erase it. I'm gonna write it in blue to help. Okay, so if I look at this first situation, okay, this would be the big arc, the big intercepted arc. Okay, and we're talking about intercepted. This would be the small or the little arc. Okay, this is the big intercepted arc. This is the little intercepted arc. This is the little one. That is the big one. Questions? Okay, let's apply some of these and use them in a problem. So if I look at this situation, we need to find the measure of arc xy. First off, are those lines intersecting on the circle, in the circle, or outside the circle? On the circle, right? So that's going to be situation 1. What's our rule there, Alex?
Measure of angle 1 equals 1/2 measure of AB but y.
Okay, so it's going to be 1/2 the intercepted arc. Okay, so, excuse me, 1/2 the... Yeah, that's what I said. I said that right. 1/2 the measure of the intercepted arc. Now, be careful. What are they asking here? X, Y. Does X, Y go that way or that way?
It goes that way.
The top one or the bottom one? Why the top, Katie? Why is it the top? Would you guys agree with me that the diameter, or excuse me, the center looks to appear to be down there?
Mm-hmm.
So this would be a major or a minor arc? Minor. And if it's major, we're going to use 3 letters, right? So since it's 2, we want the shorter way around. So we are talking this way. And so this angle is going to be half the intercepted arc. Now, let me just explain something I always got confused on. This angle, 80 degrees, does not go from the circle to that line, okay? It goes from the line to the line. So it goes from the tangent line to the chord. And so this angle is going to be half the intercepted arc, which is xy, which is how much? Double it, 160 degrees. So the angle is half, which means the intercepted arc is double. Okay, second situation. They intersect on, inside, or outside?
Inside.
On.
On.
I think it'd be on, right? Now, it's asking for major arc. RST. So they want this arc right here. Which is what?
196.
196. Guys, can I tell you something? A question that oftentimes gets confused is this one. Measure of arc like RT. So they would give this to us, this information, but they want to find this part of the circle. Couple ways to think about it. We could find this arc first, which we just did, and that's 196. And then this part of the circle is going to be 360 minus that. Would you agree there? Okay. Another way to do that would be, when you agree that these two are a linear pair? So we could take 180 minus 96 to get this angle, or excuse me, 98 to get this angle, and then double that. Okay, so it's important to understand, hey, what are they asking? What angle are they asking us? And which angle are we given? Okay, just don't assume that the one that they're given is the one we're going to be using. Okay, this next one, here I've got this angle, angle 1. Our intercepted arc is 210, so angle 1 has to be half of that, which is going to be 105. Okay, now as we look through these four, okay, I've got two of them that intersect inside the circle, which would be the first one and the fourth one, and then two of them that intersect outside the circle. So let's do 1 and 4 together because they're similar. All right, now, what's my formula here to find this angle? Okay, it might almost be better to look at the words. What did I say in words there? It's the average of the intercepted arcs. So the intercepted arcs would be here. 156 and 130. So angle X, this angle is going to equal 1/2 the average. So average is 1/2, and then we're going to add them together. 130 plus 156. So I'm going to take 130 plus 156, hit enter, and then times it by 0.5.
143.
And we get 143, don't we? Okay, I like that one. Now, a couple things that's different on this one. First of all, our variable, our missing piece is not this angle. It's actually an arc. So that's how this one's different than the first one. Secondly, second reason this one's different than the first one is, if you take a look here, this angle right here is not, if you look over here, and I don't know how to verbalize it, but this angle makes this intercepted arc. Would you agree? And then we need to go across from it. Well, this angle makes this intercepted arc and go across from it. You guys see that? So we're actually not going to use 102 in our formula because that's not the angle we're worried about. We're actually concerned about this one or that one. I don't care which one. They're the same thing because they're vertical, but we're actually concerned about that one, not 102. Do you guys see that? How we need to be working with these angles because these are our intercepted arcs, but we're actually given that one. Okay? So how are we going to find that one, Morgan? This angle right there. Yeah, we're going to use the formula, but we need to do something first. Any ideas? Shane, what do you got?
Divide 95 by 2.
No? Guys, would you agree that, like, these two angles are a linear pair?
Yeah.
So if this is 102, this has to be 78.
Bringing back the old stuff, huh?
Not bringing it back, it just never left. You guys see that? Now I've got that angle, which now I can use 95, 78, and y in my formula. I don't want 102 because it's not it's not in a straight line. I don't know how to verbalize it. Okay, so now my formula is this. 78, that angle equals the average of these two arcs. Now the average of the arcs is going to be 1/2 y plus 95. So not what we're going to find, not every time is the piece that we're trying to find going to be over here. We may have to find something within the equation. How do I solve this? Serena, what do you think? Okay. Yes. What's another way of dividing by half?
What's up by 0.5?
Times by 2. Guys, let me clarify something. Could we distribute the half here? We absolutely could distribute the half. I prefer not to distribute fractions if I can help it. Because then I'm going to have 1/2 y, and that's going to give me a decimal. I would much rather get rid of the 1/2 by multiplying both sides by 2. Could I distribute? Absolutely. Do we have to distribute? In this case, no. Sometimes you do. In this case, you don't. So those would cancel. 78 times 2 is 156. So I get 156 equals y plus 95. And then to solve for y, I'm going to minus 95 on both sides.
61.
What do we get?
61.
61 degrees. So y, the measure of that arc, is 61. Two major differences from this one to the first one is A, the variable isn't in the center. So that's why we had to put 78 over there. Secondly, we're not going to use 102, excuse me. We want to use 78. Questions on those two? Okay. If I work on to the second one here, now they're intersecting outside the circle. So our formula is 1/2 the big arc minus the little arc. So in this case, that is going to be my big intercepted arc. That is my little intercepted arc, and we're finding that angle right there. So x is going to equal 1/2 the big arc, which is 178, minus the little arc, which is 76. I don't even know if we need a calculator here. What's 78 minus, or 178 minus 76?
102.
102. What's half of 102?
51.
51. So that angle, x right there, is 51 degrees. Okay, same thing over here. They're intersecting outside the circle, but things that we need to be aware of is now I know that angle, and I don't know one of my arcs. Is that the big arc or the little arc? A would be the big one or the small one? I think that'd be the big one, wouldn't it? So now I can say, all right, 30 degrees, 30 equals 1/2 the big arc, which is A, minus the little arc, which is 44. Again, how are we going to get rid of that 1/2? Times both sides by 2. So now I'm going to get 60 equals A minus 44. Yep. To get rid of minusing 44, I better add 44, and A is going to equal 104 degrees. Okay, can I say something for a second? A problem that causes people issues, if let's say I put 88 over here. An issue is when people say, hey, 1/2 the big arc minus the little arc, they think 88 is the big arc because it's the big number and it's sitting there. But that doesn't apply to this problem whatsoever because we need the intercepted ones inside the angle. Questions on these four? Okay, next two. The next one's called a circumscribed angle. We talked about inscribed things, inscribed triangles, inscribed quadrilaterals, how they're inside the circle. Circumscribed means it's just on the outside. So a circumscribed angle is an angle whose sides are tangent to the circle. Okay, and if we look at these sides, they appear to be tangent to the circle. Okay, just touching at one point, and those points are called the points of tangency. Now, a circumscribed angle theorem. So it says the measure of a circumscribed angle, right here, is equal to 180 minus the measure of the central angle that intercepts the same arc. So angle D in this case is going to be 180 minus C. So angle D equals 180 minus angle C. Why is that? Well, guys, this shape right here has how many sides? 4. How many degrees are in this quadrilateral? How many degrees are in every quadrilateral? 360, right? Now, we know that if we have tangent lines, they are perpendicular with the radius at the point of tangency. So this angle right there is 90 degrees. All tangent lines are perpendicular with the radius at the point of tangency, and that is 90 degrees. So I have a quadrilateral, 4 of the angles add up, all the angles add up to 360 degrees. Well, if I take a look, I've already used 180 there, haven't I? So that means these other two have to be left for 180 degrees, and that's why this theorem works. Last example. Now, one thing that I'm kind of, again, if it appears tangent, we got to go with tangent. There's no proof. There's no proof that it's tangent. It doesn't say that's tangent, unless, because there's a point there, but if it looks tangent, it's going to be tangent. So x is going to be what? 45. 180 minus 45. Excuse me, minus 135. Okay, now this one's different, isn't it? Isn't it?
Yeah.
How are we going to go about this guy? Chris? Can you explain that?
So 30 equals 180 minus x.
Okay, now here's the issue. This angle is going to be 180 minus the central angle, that angle. Central angle here, this is not a central angle, but rather that's an inscribed angle. See that? Sydney, any ideas?
Could you take 180 minus 30 to get your G angle?
The red one that I drew up there? So what Sydney said, so guys, if I have this shape here, where I go from H to E to G to F, this shape, this angle right here is going to be 180 minus 30, which is what? 150. That is 150 degrees. How does that help us find x though, Sydney?
Because then you just divide them by 2. So
Divide it by 2.
then you get one of the angles.
Keep going. Can you say that a little louder?
Because then you would get one of the angles. Because those two angles equal 150.
What two angles do?
J and
J? So you're saying x is 150?
No, no.
You're onto something. You're just not quite right. Would you guys agree that x, or angle J, is inscribed?
Yeah,
What do we know about inscribed angles?
they're half of the arc.
They're half of the intercepted arc. Well, what is the intercepted arc of angle J?
90.
It's this arc right here. Isn't it?
Yeah.
How many degrees is that intercepted arc? What do you?
150.
It's 150 because the central angle is 150. We've been saying that for a couple class periods now. The measure of the arc is the same thing as the measure of the central angle. So if this measure of the central angle is 150, then this measure of the arc is 150. And so x needs to be half of the intercepted arc. 75 degrees.